In the previous lesson, you learned how to find the least common denominator of two or more fractions, so rational expressions. So if you recall these problems right here. So the LCD here was x plus 3x minus 2. Remember, one of the things you also did was you factored the denominator before finding the LCD. So in this lesson, though, you're going to use the same idea. So what you learned in the previous lesson, you're going to use here, but in particular, you're going to write equivalent fractions. So let's review something about writing equivalent fractions. So from 2 semesters ago, let's suppose you had the two fractions, 5 eighths, and let's say the other one was, let's say 7 twelfths. All right, so I made that up real quick. Okay, so first of all, when adding or subtracting fractions, you had to make sure that the denominators are the same. So you had to find the LCD. So the LCD here of 8 and 12, of 5 eighths and 7 twelfths, so these come a multiple of 8 and 12 would be, and if you can't figure out right away, you could do the factor tree. So remember we talked about the factor tree. So 8 is 4 times 2, 2 is prime, 4 is 2 times 2, and so 8 is 2 to the third power. And 12 would be, let's say 4 times 3, 3 is prime, 4 is 2 times 2, and so this is 2 squared times 3. And so the least common multiple of 8 and 12, so the LCM of 8 and 12, you look at all your factors. I have factors of 2's in both of them, and really it doesn't matter if they were in both or one of them. It does not matter for the least common multiple. For the GCF, it does matter, but for the least common multiple, it doesn't matter. So you got to distinguish between GCF and LCM. Okay, so I have factors of 2 here and here. I have a factor of 3 here, but none here. But I will still need a factor of 3 in my least common multiple. So remember we talked about, so for 8, which is 2 to the third power, there are 3 factors of 2. Here there are 2 factors of 2, so I need the one with the largest amount of factors. So I need 2 to the third power. Over here, I have one factor of 3, none here, but I need one factor of 3 here. And so 2 to the third is 8. 8 times 3 is 24. So the least common multiple of 8 and least common multiple of 8 and 12 is 24. So that means the least common denominator of these two fractions is 24. And so when we talk about writing equivalent fractions, we're asking ourselves, I need to rewrite 5 eighths, this fraction here, into an equivalent fraction with the denominator 24. And so what we did 2 semesters ago was we asked ourselves, well, first of all, 8 times what is 24? Well, 8 times 3 is 24. But what I do to the denominator, I have to do to the numerator. So 5 times 3 is 15. So 5 eighths is equivalent to 15 over 24. And then remember what we did also 2 semesters ago was to check ourselves. We kind of reduced this. 15 divided by 3 is 5. 24 divided by 3 is 8. All right. Now let's do the 7 twelfths. So 12 7 twelfths is equivalent to what fraction with a denominator of 24. So we did the same thing. 12 times 2 is 24. What I do to the denominator, I do to the numerator to keep it equivalent. 7 times 2 is 14. So 7 twelfths is equivalent to 14 over 24. All right, so that's what we mean about writing equivalent fractions. Okay, now 2 semesters ago, all you dealt with were numbers, no variables at all. Now you're going to look at writing equivalent fractions for rational expressions that contain variables. So let's look at this first example. So let's suppose you had 3 divided by 2x, and the question is 3 divided by 2x is equivalent to what fraction with a denominator 4x squared? So that's the question. So 2x, 3 divided by 2x is equivalent to what fraction with a denominator 4x squared? So what they're asking you to do here is to indicate what the numerator is. So the numerator What does the numerator need to be? And so that's what you would put in the blank. Okay, so what you may want to do is kind of like we did here. So we looked at what we needed. We had an 8, so we asked ourselves, and this was easy because it was just numbers. So we asked ourselves, 8 times what is 24? Well, 8 times 3 is 24. What I do to the denominator, I do to the numerator. So that's how I got the 15. So do the same thing here. I have a 2, I want a 4. So what do I need to multiply this 2 by to get a 4? Well, the answer is 2. So times 2, so I'm going to use purple here. And then I have an x. Well, x times what will give me an x squared? So it will be 2x. So I need to multiply this denominator by 2x, so that way I'm going to get 4x squared. All right, so because 2x times 2x is 4x squared. But what I do to the denominator, I have to do to the numerator. So 2x times 3 is 6x. So that's my numerator. My numerator will need to be 6x. Okay? All right, let's go to number 2. And you can always check yourself. If you reduce this, let's say 6x over 4x squared. If you reduce this, 6 and 4, they both have a 2 in common. So 2 divided to 4 is 2. 2 divided to 6 is 3. So hence 3 over 2 right here. 3 over 2. And then, remember we talked about, I have one factor of x in the numerator. I have two factors of x in the denominator. So I'm going to simplify, divide all this out with factor 1. This factor of x, when I simplify into two factors of x, I'm left with one of them. So I get 3 over 2x, which is what this was. Okay, so you can always check your work. You can always check. Okay, all right, number 2. Suppose we had 6 divided by 3a equals, and I want a fraction with a denominator of 12ab squared. 12ab squared. All right, so these are monomials. These were monomials. These were monomials, so no big deal. It's not that difficult. So first of all, look at the coefficient. 3 times what is 12? Well, the answer will be 4. So I'm going to have to multiply this by 4. A, see this is an A. I already have an A. Because A times 1 is A. Okay, but let's just leave the 1 off, right? Let's leave the 1 off, because 4 times 1 is still 4. All right, so I already have the A. So if I cover the B squared, do you see that 3a, and you may need to do that sometimes, cover what you're not looking at so far. If I cover the b squared, do you see that 3a times 4 is 12a? All right. Okay. Now I need a b squared. I don't have a b squared here, so I need to multiply this by b squared. So b squared, and then check your work. 4 times 3 is 12. A times b squared is ab squared. All right. So that's what so that right here is what I multiplied the denominator by. But what I do to the denominator, I need to do to the numerator. Okay, so see the thing I have underlined? You may need to underline it if you need to. 4b squared, 4b squared. So multiply the numerator by 4b squared. 4 times 6 is 24, so I get 24, and then b squared. So that's my numerator. So the numerator needs to be 24b squared. All right, number 3. Suppose you had 9 divided by 2x plus 6 equal, and you want to write an equivalent fraction with the denominator of 2y times x plus 3. All right, so 9 divided by 2x plus 6, and you want to write an equivalent fraction with this denominator, 2y times x plus 3. So what you need to do first is factor. See how these were monomials right here? 2x, 3a, 4x squared, 12a b squared. You want to factor this denominator. So when I factor this denominator, that's going to be 2 times x plus 3. Okay? All right, so make sure it's factored. All right, so I need to multiply this 2x plus 3 times something, times some factor, so that way I end up with this. So first of all, if you look at the 2, I already have a 2. All right, so if I cover everything except the 2, you see you already have a 2, right? There's a 2 here and a 2 here. I already have an x plus 3 right here, so I need an x plus 3. I already have it. What is the only thing that you see that's missing? What is missing here that you have here? All right, so see, you already had the 2x plus 3. All you need is a y, so you got to multiply this denominator by y. And when you multiply by y, you see you get 2y, x plus 3. But what I do to the denominator, I have to do to the numerator. So y times 9 is 9y. So 9 over 2x plus 6 is equivalent to 9y over 2y times x plus 3. So my numerator, so it's going to ask you for the numerator. So in the numerator, you're going to say 9y. All right, number 4. All right, number 4, you have x divided by x cubed plus 6x squared plus 8x is equal to, and you want this fraction to be equivalent to a fraction with this denominator, x times x plus 4 times x plus 2 times x plus 1. Just make sure that the division symbol here is extended. All right. So again, see how this is already in factored form? You got to make sure this is in factored form. And this supposed to be x plus 1 right here. So x plus 1, that's a 1. All right, factor this. So first of all, I can factor out an x. So I get x times x squared plus 6x plus 8. And then see if you can factor this trinomial. So when I factor it, that becomes x times x plus 4 times x plus 2. So that's what this is. So this denominator is this right here. All right. So remember, I want to rewrite this fraction with a denominator that has this denominator. I'm sorry, with a fraction. I want to write this fraction as an equivalent fraction with this denominator. So you got to look at what's missing. See, I already have an x. So if you need to circle the ones you already have. I already have the x. See it? I already have the x plus 4. I already have the x plus 4. And I already have the x plus 2. So the question is, what do I need to multiply this denominator by to get this denominator? And the only thing that's missing is the x plus 1. So you're going to say times, in parentheses, x plus 1. But what I do here, I have to do here. Okay, so x plus 1. So times x plus 1. All right, now here's the what you got to remember. In my math lab, there are going to be some situations where they're going to ask you to not leave this in factored form. So you're going to distribute this, and so you're going to get x times x is x squared, and then x times 1 is x. All right, so the numerator then is going to be x squared plus x. So they will ask you not to leave the numerator in factored form. Leave the denominator in factored form, but don't leave the numerator in factored form. Just go ahead and distribute. Get rid of the parentheses here using distributive property, and you get x squared plus x. All right, number 5. Suppose you had, let's say you had 5x divided by x squared. Actually, that's x cubed plus 2x squared minus 3x equal, and then you want this fraction to be equivalent to this that has this denominator x minus 1, x minus 5, x plus 3. All right. So again, we have to see how this is in factored form and this is not. So you got to factor this. So factor out the x. I get x times x squared plus 2x minus 3. And then factor this trinomial. So I get x times x plus 3 times x minus 1. All right, now the best thing you may want to do is to see what you need to multiply this by to get this is circle the ones you already have. See, I already have the x here. I already have the x plus 3 right here. I already have the x minus 1, and the only thing that's missing is x minus 5. So what I got to do, what I have to do is multiply this denominator by x minus 5. And what I do to the denominator, I have to do to the numerator. All right, what you do to the denominator, you do to the numerator, but remember, do not, and so this is going to be, so this is going to go here, right here, but don't, it's right here, but don't, they, in my Math Lab, they want you to not leave it in factored form. So you're going to say 5x times x and then 5x times a negative 5. So you're going to use the distributive property. So the answer is going to be 5x times x is 5x squared, and then 5x times a negative 5 is a negative 25x. So in a blank, you're going to say numerator is going to equal 5x squared minus 25x. Okay? All right, so that's going to take care of this lesson.